Okay, so in this video clip, I'm going to make a direct comparison between Black Scholes Monte Carlo and then a closed form solution. So we're going to compare the actual Black Scholes estimate of European options and compare the closed form solution directly against the Monte Carlo estimation using Monte Carlo simulation. And we're going to set that up in Jupyter Notebook. So first thing we should do is copy this snippet of code, and it basically is a blend of code, Monte Carlo simulation, and then we have some Black Scholes modeling here as well. So we go into, first thing we must do is go into the Anaconda navigator. And then we launched the Jupyter Notebook, and generally that's relatively fast in appearing. And we go back into, might pause here for a moment. Okay, so we've resumed. Next thing we should do is create a new project, and it's Python 3. And of course we can give it a name, Black Scholes closed form solution, Black Scholes closed form versus Monte Carlo simulation. Okay, so that's there. Let's rename, and we just paste our code in. And to get this code to execute, you hold the Shift button and Enter, and we have output. And the first two lines are the Black Scholes output for the parameter inputs that we have here: S100, K exercise is 100, T is 1 year, R is 5%, Q is 0, so no dividend yield, and the volatility of 20%. And we typically get 10, 45, and 557 as true. And then the Monte Carlo estimates appear below, and they're a little bit out. Now, if we increase the number of steps, 1, 2, 3, 4, 5, 6, we have 1 million there. Perhaps if we go to 500, 5 million, and Shift Enter, and that takes a second, and perhaps it's worth pausing. And as it turns out, it didn't take so long. We're quite close. So the Monte Carlo estimates for the call and the put are very close to the true Black Scholes values of 1045 for the call and 557. Now, in this instance, we have values here for dividend. If we change this to 5, right, because of put call symmetry and put call parity, we should get the same value for both the call and the put. Okay, so let's run this again. Control Shift, Control and Shift. And we're also trying to demonstrate that the dividend yield that we've included in the Monte Carlo formula, the dividend yield we've included in the Monte Carlo. So if we go to the Monte Carlo formula, you can see we have reference to Q. And the drift term also has Q included, right? And the effect of including that means we can enter that into our estimation with 5 million simulations, 5 million runs. And for the true values, you can see here 757.7. So the call and the put for Black Scholes are exactly the same. And we have a value for the Monte Carlo estimate also that is consistent with the Black Scholes. We could do one more estimate here where there will be a difference now between the value of the call and the put. Let's change Q to 6 and let's run that. So Control Shift, Control Shift, and so I should have said Control Enter, sorry, Shift Enter, Shift Enter, the value of the Black Scholes call is 707. The value of the Black Scholes put is 8.022. You can see the Monte Carlo value is very close to the Black Scholes, and the Monte Carlo value for the call for the put is very close to the Black Scholes value for the call. So we have reached convergence. So it would appear that the formula here is for Monte Carlo. This algorithm seems to be working, and we've managed to test it a little bit. Okay.